we mentioned entanglement, but we haven't really defined it yet for anybody. So maybe I should do that very
Yes.
quickly. So entanglement is this very bizarre property in quantum physics, right? Where you could have two particles and they could be separated by the size of the universe, right? One on one end of the universe, one on the other end. And if they are entangled, manipulating, measuring, doing something to one of those particles will instantaneously affect the properties of the other particle, which is just mind blowing because Einstein, right, has famously said there is a speed limit in the universe, and the speed limit is the speed of light. You can't go faster than the speed of light. And so now you have this phenomenon that looks to transmit information faster than the speed of light, which breaks all of our rules, with entanglement. It's just like mind blowing that you could have two entities communicating with each other instantaneously.
Hmm.
Now, we can't yet use entanglement to do like a instantaneous communication. Why? Because in all of these properties, in all of these protocols, there's always a classical phone call that has to go along with it. So even if the superposition state between the two particles has collapsed, and Alice has done the measurement and Bob has the answer or whatever, it's actually still random. And they need to have what's called a reconciliation. They have to have a phone
Hmm.
call. Alice and Bob have to make a public announcement, and it's part of the protocol. And so until they do that, even though they technically do have the collapsed states, it's not useful information yet. I know that was a big
No,
rabbit hole.
no, no, no. But I love your explanation.